This is Jeremy Clark of JeremyBytes.com, and today we're going to be doing a bit of refactoring. This is from a session that I do called Clean Code Homicidal Maniacs Read Code 2. And the problem with the session is I've got this really great refactoring part, and I usually only get through about half of it during the time that we have allotted. So what I'm going to do here is record the entire refactoring bit so that it's available for you to watch. The rest of the information is available on my website, so just follow the links on this video and you'll get a PDF walkthrough that actually goes through all of the topics that we talk about with Clean Code, and that also does a walkthrough of the refactoring parts as well. On the website, you'll also find the code samples, so if you want to follow along, you're free to do that as well. So let's head over to Visual Studio and see what we've got. So let's start by running the application, and what we'll see is a fairly straightforward user interface. Here we have a refresh catalog button, and what that will do is it'll refresh the items in our list box. We also have a last update time, and that tells us the last time we fetched data from the server. We have a selected items box, and this will allow us to add items. We can double click to select items, and then we can double click here to remove items, and we can also clear the list box as well. And then we have a set of filters, so we can filter based on the year that's on each of our items. So we can actually filter all of the items if we want, but we'll just show the items based on a particular decade. When I click the refresh catalog button, it will reset the filters as well as the last update time, but we also have a 10-second cache built in. So if I click the button again, notice it says 3:15:11. It still says 3:15:11 because we haven't exceeded that 10-second cache, but our filters did reset as well. So we can see our filters reset regardless of whether we're using cached data or fresh data from the server. And this is, again, just kind of standard functionality. This is based on a real application. That real application had about 40 different projects in it, about 12 different modules, so it was fairly complex. What we've done is simplify things quite a bit. So if you look at our solution, we actually have 6 projects, and it's broken down into 2 sections: stuff we care about and the rest of the application. The Stuff We Care About section has a module for our catalog as well as a test project for that module. The rest of the application has some infrastructure stuff. It has some WCF services. We're also using a dependency injection container and a few other things. So that's all happening in the rest of the application, and we're not going to be taking a look at that. There's actually 2 files that we really care about. We want to look at the view model that we have in our catalog module, and we want to look at our tests for that catalog. So let's start out by looking at the view model. Now, if we just take a high-level look at this, we see we have some regions, and this region layout, it's something that I used for many years when I was working on a team, and I got used to it, so I started using it in my regular programming. If you do have some kind of organization like this, the important part is that your entire team agrees to it. So we're looking for consistency so that when developers walk up to other applications that they might not necessarily have worked on themselves, they'll see similar layouts and nothing will be a surprise. The idea here is we want to make things completely unsurprising and hopefully self-descriptive. Now, one thing I do want to point out before we do any refactoring: the code we're looking at here is not bad code. So we're not looking at ugly, nasty code. What we're looking at is reasonable code, but our goal is just to make it more readable. Now, before we look at any code, let's look at the tests for the code. Now, notice that our view model that we have here has 242 lines of code, so it's fairly compact in and of itself. If we go to our test project, what we'll see is several regions as well. Each piece of functionality does have a unit test behind it. So the things to do with the caching, the things to do with the filtering, the selection of the items, it's all in our unit tests. In fact, if we open up our Test Explorer, we'll actually see those tests. So we have 19 tests, and I'm going to go ahead and click the Run All button so that we can see all of our tests actually work. So before we even start refactoring our code, we see that we have good test coverage. This is important because when we're doing refactoring, Our goal is to make the code easier to read for a developer without changing the functionality. So our unit tests will here to keep us honest. If we end up inadvertently changing functionality, our unit tests are going to pick that up. So it's extremely important to have good unit tests in place. Now, one thing I like is I like this button right here. This is available in Visual Studio 2012. And you can see it says Run Tests After Build. This is actually a toggle button, so we'll toggle that down. What this means is every time I change code and rebuild an assembly, the Test Explorer will automatically rerun any affected tests. Now, in our case, we're dealing with a single view model and we're dealing with a single unit, a single set of tests. So it will actually rerun all of the tests every time we change our code. Now, before we move on to refactoring, let's talk a little bit about why managers don't like unit testing, because a lot of times they'll just look at the lines of code. Look here, we have 488 lines of code in our tests. In our view model, our actual production code, we have 242 lines. So someone who doesn't know any better is going to walk up to this and saying, you're writing 3 times more code than you actually need to. And that's not the case. They seem to think that if I could type faster, that I could write more code. Think about this. If you could type twice as fast as you do now, would you be able to write twice as much code? The answer is probably no. Most of us spend our time trying to solve problems in code. It turns out that the unit tests allow me to work more quickly. Let's take this scenario. Again, this particular application is based on a real world application. But let's say this screen that we're working on is 4 screens into a workflow. That means if I were to just test it manually, when I changed functionality in my module, I would have to start up the application, enter the data for the first screen, enter valid data for the second screen, enter valid data for the third screen. Then I get to the 4th screen to see if my code is actually doing what I expect it to do. That is not very fast. On the other hand, if I have unit tests in place, I can see very quickly whether my code is doing what I expect it to do without having to go through that 5-step process to get to the screen that I need. Now, I will still do those manual tests from time to time, but with the valid unit tests in place, I can actually put together larger chunks of functionality before I start really checking to make sure that they all work together. So having unit tests actually allows me to work more quickly. So just because I have more lines of code, that doesn't mean that I'm going slowly. Okay, so now that you're convinced unit testing is a good idea, let's take a look at refactoring our code. We're going to come in here, and our goal here is to do something that I like to call intentional naming. And again, if you review the slides and some of the other things from this particular session, you'll see that the way we name things is very important to get our intent across to other developers. So that's what we're going to focus on. Let's look at this initialize method right here. Now, if we look at it, it's not very long. There's only 9 lines of code. And again, is this bad code? No, it's okay code. There's nothing wrong with it. But it is very difficult to walk up to for the first time. You're probably staring at this code right now and kind of scanning through it and trying to figure out what it does. And that's what you would expect from any developer who's walking up to this code for the first time. So me, as someone who's been up to my elbows in this code, what can I do to make this easier to work with? Because you know what's going to happen? 6 months from now, someone's going to ask me to make a change for the code, and I might not remember exactly how it works, so I have to look at the code and use it to figure it out for myself. So what we're going to do is we're going to put up a set of hierarchical functions. So our initialize method will be a high-level function. It will just show the basic big chunks of what we're trying to do. Then we'll drill down into more detailed functions that will have the actual functionality in them. Let me show you what I'm talking about. So let's start with these first 4 lines. Now, I could tell you exactly what this is doing, but the easiest way to do it is refactor it so you can see what it's doing for yourself. So we're going to right-click and say refactor, extract method. And notice the keyboard shortcut here is Control-R, Control-M. We'll be using that throughout the rest of this demo. So if we extract the method, let's give it a name that is talking about the intent of the code. What this code is doing is it's actually getting the service from our dependency injection container. So we'll call it getServiceFromContainer. Now, anyone who's working with this application would know that we're using dependency injection, and so hopefully they know we're using a dependency injection container, and this method would be understandable from its name. Now, the first thing I want to do is actually build and rerun my test just to make sure I didn't break anything. So let's go ahead and do that. And if we watch our test explorer, we'll actually see our tests rerun. And there's our tests running, and there they are, all of them have passed. So we haven't actually changed functionality at this point. Now you've noticed I'm kind of popping open the test explorer and closing it again. In my real development world, I have a dual monitor setup. Hopefully you do too. I like to have that test explorer window open on my second monitor. So every time I build, I see the results of the tests and I see immediately if I broke anything. Now this method getServiceFromContainer, it's fairly clear from the name what it's doing, but what it's actually doing is assigning to our service field. This is the backing field for a property that we're using in this part of the view model. What I'd like to do is I'd like to move this assignment back up to the initialize to make it a little more clear. So instead of returning void, we'll have this return the iPersonService. And here, this part where we're assigning this, I'm going to cut that, Control X, and we'll just return that value. And up here in our initialize method, I'll paste that in. So you can see now what we're doing is we're getting the service from the container and we're assigning it to our _service field. Let's go ahead and build. And again, we'll make sure that all of our unit tests work. Let's go ahead and pin these in place. Okay, so we see them all passing. And what I'm going to do is I'm just going to make this little so that we can see the green lights pop up every time we build. So the next 4 lines of code are actually doing something similar. They're getting the model from our dependency injection container. So we'll go ahead and highlight this and we'll say refactor extract method, and we'll call this getModelFromContainer. And then just like before, I want this to return the catalog order, which is the type, rather than assigning to the model directly. So we'll just return that. And let's go ahead and build. Now, if we build at this point, now we see we actually have some failing unit tests. If we look at these, this is where I'm glad of the naming method that I use for my unit tests. So we have a failing test called model on initialization is populated. Here I'm actually using a naming scheme recommended by Roy Osherove, who wrote The Art of Unit Testing. This is a 3-part naming scheme where the first part is the unit under test. So in this case, we're testing the model property. The second part is the action that we're performing. In this case, on initialization, we're calling the initialize method. And the last part is the result that we're expecting. In this case, we're expecting that the model property is populated after we call the initialize method. Well, we can see we don't have that in this case. And the reason for that is I actually forgot to go ahead and do the assignment after I updated my method. So again, what we can see here is that having the unit tests in place keeps us honest. It makes sure we're not accidentally changing the functionality of our code. And if we go ahead and rebuild, we'll see that all of our unit tests now pass. Now, one thing you might have said is, hey, wait, there were like 6 failing unit tests, but you only fixed 1 of them. Well, the reason is those other unit tests were failing because they were trying to use that model property. Now, those tests weren't specifically testing the model property, but they were trying to use it. So when it tried to access the property, there was a null reference exception. So sometimes when you do make failing tests because you mess up the code, you end up with cascading failures. So you might have multiple unit tests fail, and you fix one thing and all of them start to pass again. That's a pretty common situation. In fact, in my own work, we had 600 unit tests for our view models, and it was very common for me to break 20 tests at a time. And when I was doing that, I needed to go in and check, do I need to change the test because it's no longer valid? Or do I need to update my code because I was breaking something? In this case, we're simply refactoring. Our goal is to not change any functionality, which means our unit tests should stay valid. If we end up breaking a unit test, it's because we made an unintentional change. We want our functionality to stay the same. So now that we've extracted these methods, let's take another look at this initialize method. Now it's much easier to tell what the intent is of this method. First, I'm getting the service from the container and assigning it to a service field. Next, I'm getting the model from the container, assigning it to the model field. Then I'm refreshing the catalog. The best thing about this is if I need to come in to debug something or add functionality, I can glance at this, get a really good idea of what I need to drill into. So if I don't care about how things come out from the container, because that's not the piece of code I'm dealing with, I don't have to look at those details. I can focus on just the pieces that I need. So by having these hierarchical methods, it allows us to take very clear paths through our code. Let's go ahead and continue along with this with the refresh catalog method. If I scroll down a little bit, we'll come to that. So here's our refresh catalog method, and again, not a bad method. It's a little bit longer than the screen, which I try to avoid, but it's still only about 30 lines of code. So it's not like a giant method with hundreds or thousands of lines of code. It just has 30 lines of code. But again, let's see what we can do to make the intent of this method more clear. Now, as I scan through this method, I see one problem right off the bat. If we look at lines 161 and 162, and compare that to lines 174 and 175, we have duplicated code. And again, we want to follow the dry principle. Don't repeat yourself. If you have two sections with the same code, they really should be combined. So let's go ahead and extract this method. What's it doing? Well, we have these different include 70s, include 80s, include 90s. These actually have to do with those filter properties. And then we're calling the method refresh filter. So if we want to extract this method, we can call this something like reset filters to default. And then we can use this same set of code down here. So that eliminates the duplication of that code. Now let's go to our Test Explorer, pin it in place and run, and make sure that our unit tests all come up green. And we have passing tests. And just to show the importance of having thorough unit test coverage, let's go ahead and comment out one of these items. Now if we build, we'll see we actually do get a failing test. So here we have a failing test, and this has to do with our cache not being expired. So let's go ahead and put that one back and see what happens if we comment out the other one. Now if we run this, we will get a failing test as well, but this will be a different test. In this case, it's saying filters on refresh and cache expired are reset. So here we do have unit tests that are covering these different scenarios. So this is really great as a safety net for me when I'm trying to refactor. I know that every time I make a change to the code, whether I've actually changed the functionality. Again, here, I don't want to change the functionality. I just want to make it easier to read. Let's go ahead and reduce this guy back down again. And let's take a look at this if statement that we have. The conditional here, again, not hard to understand. What it's trying to see is if something is less than 10 seconds old. Okay, and again, a little parsing of this, not difficult to figure that out. But the question is, why are we checking this? Well, it actually has to do with the cache. We want a 10-second cache in this case. So this if statement is actually asking, is the cache expired? So let's go ahead and create a property for this. So we'll call this a public bool called isCacheValid. And in here, we'll have a getter, and we'll just cut and paste this into our getter. So we'll say return the results of that. And now in our conditional, we can just check to see if the cache is valid. So again, this tells us the intent of why we're checking this. And again, in a real application, you're probably not going to have a hard-coded 10-second cache. It's probably going to be coming from configuration or from somewhere else. Now, one thing I want to do as long as I created this public property is move this up to the properties section. So we'll come up to the properties section and we'll go ahead and just put it down here at the bottom. And let's build our application. And again, we want to make sure that all of our tests complete successfully. So we can see we do still have passing tests for everything. So let's collapse our properties and head back down to our methods. So now we can see this refresh catalog method is starting to become more clear what the intent is. If the cache is valid, we want to reset the filters. Else, we want to do something else. And again, what can we do to make this else statement more clear? Well, we can extract this as a method as well. Now, what this is actually doing is it's going out and getting the data from the service. So we'll extract the method and we'll call this populate catalog from the service. So now let's take a look at our refresh catalog method. How much easier is this to follow? If the cache is valid, we reset the filters to the default state. If the cache is not valid, we populate the catalog from the service. Makes it very, very easy to read. Now I'm going to do one more thing to this method that is a little controversial. I'm going to remove the curly braces. Now I know some people don't like to take out the curly braces because if somebody adds another item to the else statement, maybe they accidentally make it so it runs all the time. This is a discussion you should have with your team and figure out which convention you want to follow. One thing that I do is I use the automatic formatting that's available in Visual Studio. So for example, if we have code that looks like this and I do Control-K, Control-D, Visual Studio automatically handles the indents for me. So I can see which statements go with the if, which goes with the else, and which would be at the same level. So now that we have a refresh catalog method that's easy to read, let's go down to this populate catalog from service. Now this code is a little complex. That's because we're dealing with an asynchronous service call. We're turning it into a task that we can put on the background thread so that our UI stays responsive. Now this would be a great candidate to use async await, but unfortunately this application was written so it has to run on Windows XP machines, and unfortunately .NET 4.5 won't run on XP, so we're stuck with .NET 4.0. But we can do a few things to make this code a little bit easier to follow. One thing has to do with this block of code at the end. So we have about 6 lines of code. And what this is actually doing is it's looking for an exception that's happening on the background thread. So if an exception is thrown on the background thread, what we actually want to do is capture that, rethrow it on the UI thread, because we have a global exception handler running on our UI thread. That global exception handler will make sure that this exception gets logged. It will alert the user with an appropriate message, and it will reset the application as appropriate. So in this case, we just want to get the exception off the background thread onto our UI thread. But since this is an exceptional case, let's go ahead and wrap this in a method. So we'll say refactor extract method, and we'll call this check service exception and rethrow on UI thread. Now that method name is a little bit longer than I would like it to be, but it gets the point across that this is actually checking for exceptions that happen. One interesting thing to note is Visual Studio noticed during the refactoring process that we were actually using a task in the block of code we wanted to extract. So it automatically added a parameter for us. So the refactoring tool's very easy to work with. Now, as you've noticed, I'm using the Visual Studio built-in refactoring. A lot of developers will run with ReSharper or Just Code or a whole bunch of other different refactoring tools. They have a lot of functionality and they can be extremely useful. I'm using Visual Studio refactoring just because that's what everybody has in the box. So what else might we want to do to this method? Now, in the session when we talk about comments, we say that comments should not be used to tell what code does. If we need to explain what code is doing, we need to rewrite the code to make it more clear. But we can use comments to describe intent or consequences of code. In this case, we're actually setting the catalog to an empty list. So someone might ask why we're doing this. So let's go ahead and drop a comment. So we'll say clearing the catalog will clear any bound elements in the UI. So this will have an effect in our application of clearing the list box while the background service is running. So this way, when someone clicks the button, they get immediate feedback because the list box will empty out. Then when the asynchronous service returns, it will populate that catalog property again and we'll have data in that list box. So this will give us an idea of why we're actually clearing out this catalog. So next on the list, we see that this catalog is getting cleared out here, but it's not very obvious where that catalog property is actually getting set. This continue with block is what's happening after our service returns. So let's actually click into this reset filters to defaults. And let's click into this refresh filter. I have an inkling that this might not be named appropriately. So if we look at refresh filter, what it's actually doing is updating the filter, taking the internal people collection that has all of our data in it and applying the filters. And then we can see at the very bottom, it's assigning to the catalog property. So maybe rather than calling this refresh filter, we want to call this something different. So let's go ahead and rename this. So let's go ahead and say refactor, rename, and let's call this update catalog with filter. Now we have a lot of options in the rename box. We have a preview that will tell us everything that will be changed. We also have options to search in comments. So if we had comments that mentioned refresh filter, those could be updated as well. We can also search in strings and rename overloads. In our case, we don't need to do any of this. Let's just look at the preview. So when we look at the preview, we can see everywhere where this refresh filter was called. And down in the lower box, we can see that it will be replaced with update catalog with filter. So if we say apply, it will apply it through everywhere in our application. Now, one last bit of refactoring that I want to do actually has to do with these filters. Now we're using a subtractive filter here just because it's really easy to create link statements that chain together using it that way. But let's look at this first where statement that we have here on line 246. So we have p.startdate.year divided by 10 not equal to 197. Now I don't like this because this isn't really telling us what the intent is. What we want to do is check for a decade. In this case, we want to see if the start date is within the 1970s decade. So what we could do to make it a little more clear is I could go ahead and change this to a 1970 and then go ahead and multiply this by 10. Now, because we're using integer math here, if we take our year, let's say 1975, we divide it by 10, it will just truncate the 5 and we're left with 197. Then if we multiply it by 10, we end up with 1970. So by doing integer math, we can actually turn the start date into a decade. Now the problem with this code walking up to it is if I saw this for the first time, I would say, we're dividing by 10 and multiplying by 10. That's completely unnecessary because that will cancel each other out. Well, in this case, it's actually not canceling each other out, but that might be a tendency. So what we'd rather do is state the intent of this code. So what we'll do is we'll go to the person class and we'll just right click and go to definition. And I'm going to add a calculated property. And this will be an integer called start decade. And inside here, we'll just use this code. So we'll take the start year, divide it by 10, and multiply it by 10. So that will have the same effect. But this is wrapped up in a property that tells the intent. This is actually to calculate the decade based on the start date. So with that in place, we can make our code much more readable. So we can change this to start decade. And let's go ahead and do that for the rest of these. And this way, our intent is clear. We actually are comparing the decade to our filter, whether it's 1970, 1980, 1990, or 2000. And again, let's go ahead and build our application and make sure that all of our tests pass. And there's our tests running, and our tests are all coming up green. So we're in good shape right now. We've done a lot of refactoring that's made our code easier to read, but we have not changed the functionality at all. Now I'm going to do one last thing here, and it has to do with organization. I won't necessarily say this is a recommendation, but it's a preference that I have, and again, it's something that worked well on the teams that I was working with. Now right now we have a region just for methods. What I'd like to do though is have a separate region for public methods and private methods. This way we can see what parts are exposed to the outside world and what parts are internal just by glancing at this, and as we'll see by looking at the Class Explorer. So let's go ahead and end the region here, and then we'll create a new region for private methods, and we'll get rid of this end region notation since we've already got one down below. I'm going to say Control KD, and again, Visual Studio will go ahead and line things up here. And let's go ahead and just move some things into our public methods. So we have this public refresh catalog that will move up. And then some other methods that we didn't really look at. We have the add to selection, remove from selection, and clear selection methods. And we didn't actually use those in our code. So we'll come up here and again, paste those into our public method region. So now we have a location for public methods and private methods. And let's take a look at our public methods. So here we have initialize. What is it doing? Well, it's getting the service from the container, assigning it to the service field. It's getting the model from the container, assigning it to the model field. And then it's refreshing the catalog. Okay, let's go another level. What's refresh catalog doing? Well, it's checking to see if the cache is valid. If it is, it's just going to reset the filters. If it's not valid, it's going to repopulate the catalog based on our service. So I can tell very easily what this code is doing at a high level. If I need to drill into the details, I can. Let's go ahead and do a build, let our unit tests run, and make sure that we didn't forget anything. All of our tests are still green, which is good. And let me show you what the organization just did. So we're in the catalog view model class. If we pop this open and drill into it, what we'll see is all of the members that are in this class. And because of the way I organized things, everything's grouped together. So if we look at the top, we actually have a number of internal fields, and those have the little padlock next to them, which shows that they're private. Down below the fields, we have the wrench. Those are all of our public properties. And then if we look down below that, we have some cubes. Those are all of our public methods. And then down below that, we have cubes with padlocks. Those are all of our private methods. So we have everything very well organized. So what we started with, again, was not bad code. But what we have is something that's very easy to walk up to, very approachable. So again, 6 months from now, if someone asks me to make updates to this class, I can walk up to it, remember where I am very, very quickly, and navigate to where I need to make those changes. Now, if we collapse this region and look at our total number of lines, we see we have 275 lines of code. So we've added about 30 lines of code. But again, we really haven't added code. We've added curly braces and some method names, but we haven't added any new functionality. When we're talking view models, again, we like to keep our classes small as a general rule, but I'm comfortable up to about 400 lines. The reason why I let view models become a little bit bigger than most of my other classes is just because they usually have a lot of properties in them, and properties usually take up a lot of lines of code, especially if you're putting things in there like the notify property changed members. So that's it for the refactoring part of the presentation. Again, if you'd like to see the rest of this presentation, go to the links that are in the video notes, and there you will find a PDF walkthrough that will take you through all of the things that lead up to the refactoring. In that, we talk about intentional naming, we talk about proper method size, we talk about method organization, we talk about classes as well as the single responsibility principle, and quite a few other principles that help us create clean code. So again, feel free to visit www.jeremybytes.com for more information, and stay tuned for more videos to come.